All right, so we're going to start off by looking at 2.2. Okay, there's not really very much in this part. Just we're going to focus on what's called the break-even point, which has to do with when a company, basically, if they spent money to say get something up and running, a break-even point is when they finally recovered all the money they had to invest to get the company up and running, but they haven't started making money yet. They're at zero. Okay, so they haven't lost money, haven't made. So this particular company we're going to look at has costs associated with making their product, and they have what are called fixed costs and variable costs. So an example of a fixed cost, that could be something like maybe the company has to pay $200,000 a month to rent, all their warehouses or something like that. So it doesn't matter how many of the product they produce, they still have to pay the rent to use that building each month, regardless if they even use it to do anything. Okay, so maybe they pay $200,000 for that, or the $200,000 could be a salary. All right, it doesn't matter how much. It's like, for example, like with me teaching, it doesn't matter how many students I teach. I still have the same salary, whether I teach one student in a class or I teach 30 students in a class. That's fixed. Doesn't change. All right, so this is a fixed cost of $200,000. And this particular company is going to make t-shirts, and it costs them $1.50 for every shirt they make. Maybe that's the cost to run the machinery, to print on the shirt, to buy the blank shirt, to print on, all that stuff. But then they sell the shirt for $4. So they are going to make money, but it's going to take a while to start making money because they had to pay this $200,000 as a fixed cost. So let's see if we can write an equation for our cost and our revenue. So cost is money that the company spends. Revenue is the money that the company takes in. And once we come up with those two equations, then we'll graph them on the calculator and see if we can look for an intersection point where the cost and the revenue cross each other. All right, so let's start with the cost. Now, we have to pick a variable to represent, in this case, the number of shirts that we produce. And just to keep it simple, we'll assume that the number of shirts we make is the same as the number of shirts we sell. Because if you make, 1 million shirts and you don't sell any of them, well, now you've lost even more money. Okay, well, keeping it simple, we'll assume if you make the shirt, you sell it. So let's let X be, let's let X be number of shirts. And that will allow us to create a formula for the cost and the revenue. All right, how much does it cost to make each shirt? And this is a variable cost because the cost depends on how many shirts we make. If we don't make any shirts, then there's no cost for making shirts. But what does it say the cost is per shirt? Yep. Yep, it's $150. So we're going to represent that how in our cost? How would you write that? Yep, so we're going to do 1.5x. Okay, so there's the cost per shirt plus, Francesca, what was our fixed cost that doesn't change?
200,000.
Yeah, 200,000. So there's an equation that represents your cost. And Matt, what was our revenue? What did we sell the shirt for?
$4.
$4. So the revenue is the number of shirts that you sell times 4. And here's the two equations we want to graph. Now, Abigail, in this 1.5x plus 200,000, this 200,000, it's almost like y equals mx plus b. Like, what would you call the 200,000? It's your what in the graph? Yeah, it's the y-intercept. So we're going to go way up above 200,000. So let's try, well, let's set our window in a second. Let's type this in. And x is the number of shirts we sell. Jack, can we have a negative number of shirts?
No.
No, we can't make negative shirts. So 0 would be the smallest. What's the highest? We don't know. Let's try 50,000 shirts. Okay, we want to see where the cost and the revenue cross each other. That's what we're looking for. Y min? Well, neither one of these numbers can be negative. Cost is a positive number. Revenue is a positive number. You'd never have a negative amount. Now your profit might be negative. That's the difference between the two. If you take revenue minus cost, that's profit. That could be negative. But we won't have negative cost or negative revenue. So let's set that at 0. Y max. Well, we definitely got to go above 200,000. Let's try, I don't know, let's try 300,000. Let's hit graph and see if we can see where the lines cross. Okay, so there's my cost, not quite. So my cost is in blue, and my revenue is in red. I think I got to set the X max and the Y max higher. I think it would be up off the screen a little bit. So let's set the X max at, let's try 100,000 shirts. And let's set the Y max, I don't know, let's try 350. Let's graph it now and see if we can see where they cross. Yeah, I think that'll be good. Well, it's kind of close to the edge, but that's okay. So, as far as answering the question, okay, we've got the two equations. Find complete graphs. Okay, well, there is my complete graph. There's your x min, x max, y min, y max. Not the only answer, but I think that one works. Now, I might have already mentioned it. Does anybody know what we call the point where the cost and the revenue cross each other? Yep.
The break-even point?
Yeah, it's a break-even point. So the break-even point, if you want to think about it algebraically, is where C of x equals R of x. It's where cost and revenue are the same. So when you're looking at a graph, we already answered this, it's where they intersect. Can I already ask that? So for a graph of cost and revenue, it's where the cost and the revenue cross each other. So now what we're going to do is we're going to find the break-even point in our problem. We'll do it two ways. I think I have it set up to do it two ways. We can do it algebraically. We can also do it using the graphing calculator. The formulas we had for cost and revenue aren't that complicated, so it's actually not that hard to just do it without. So let's find the number of shirts that the company has to sell in order to break even. So let's do it algebraically first, which we could probably do it faster this way than graphing. Because think about how much time we already spent with graphing. We had to type something in Y1, we had to type something in Y2. We set the window, it didn't work, we had to go back in, we adjusted the window, then we graphed it again. So we've already spent maybe 1 to 2 minutes trying to graph it. And then if we want to see where they intersect, we have to go back and do second calc intercept. That only takes about maybe another 15 seconds. But still, you're probably talking about 1.5 minutes to do all the work for graphing. Let's see how long it takes us algebraically. So remember, it's where cost equals revenue. So my cost is 1.5x plus 200,000. My revenue is 4x. We can solve that equation for x in 2 steps. Anyone think they can tell me my first step to get x by itself? Yep, go ahead, Bailey.
Subtract 150 from each side.
Subtract, can you say it again?
Subtract 1.5 from each side.
Yep, so subtract 1.5 from each side. So that gives me 200,000 equals, what's that, 2.5x. And what's my last step? Francesca?
Did you divide it now?
Yep, by
2.5.
2.5. And if you do that, it will come out to 80,000 shirts. And we're done. So honestly, I think that amount of work is faster than graphing. For this, because the equations weren't that complicated. More complicated equation, maybe not. But in that case, it comes out to 80,000. Now, let's do the same thing graphically. So we already spent about 1 minute or 2 to get that picture. Now we got to calculate the intercept. Can someone remind me the buttons that I have to press to do an intersect, Matt?
Second calc. And 5.
Yep.
And then you would have, you hit enter.
Yep, enter on the blue,
And then you hit enter again.
enter on the red.
And then you would guess where it is, which would be between the blue and red.
Yeah, we can guess. The guess doesn't matter because they only cross in one spot. The guess is always going to give you the one you're closer to. Well, no matter where you put the guess, you're going to get the answer. And it tells us, I don't know if you guys can really see it, but it does say right here, 80,000. So we'd have to sell 80,000 shirts to break even. Graphically, algebraically. And the 320,000, that's your cost to make 80,000 shirts. That's also your revenue if you make 80,000 shirts. The cost and the revenue are equal at that point. If you sell more than 80,000 shirts, now you're making money. Okay, any questions on that? Okay, so that's the end of 2.2. Okay, that's all that was all that was left there. All right, so let's take a look at 2.3. So I think a good amount of this will be from Algebra 1, okay, solving linear and quadratic equations. But we'll go through it just to maybe refresh some of the things because it's been a little while since you've probably done that. So remember, when they ask you to solve an equation, basically an equation is when you put an equal sign between two expressions. So you have an equal sign in the middle, something on the left, and then another expression on the right. Do I have examples? I think. No, I don't have examples there. So this is an equation. So very simple, but it is a true equation. This is an equation. It's not true, but it is an equation. And then you could also have an equation like this. 3x equals 12 is an equation that could be true if you pick the right value for x. But the point is, these are all equations. This one has an algebraic expression in it on the left. All these other expressions are just numeric. This is the only algebraic expression I wrote. If you have an equation exactly like the one I wrote right there, where it uses the variable x, then you can say this is an equation in x. So if I ask you to write an equation on a test, and I say, write an equation in L, what I'm asking you is, write an equation using L as the variable. And that would probably be because maybe you were doing a problem about length, and it would make sense to use L. Right? You usually pick a variable that makes sense. Okay, to solve an equation, that means to find the value or values that make the equation true. So in the case of 3x equals 10, I'd be asking you to solve for the number that you could multiply by 3 and get 12 as an answer. In this case, it would be 4. Some equations, like quadratics, have more than one answer. And if you remember the quadratic formula, you have part of it that says plus or minus. Well, it's because there's two answers. So now I'm describing some of the specific kind of equations you can have, and I actually have them all up here. This first one is called an identity. An identity is an equation that is always true. It's impossible to make it false. And if you're like, well, how could that happen? Well, think of something like this. If, let's see, does that work? Yep. If you try to solve that equation, or if I gave that to like Algebra 1, you end up with 3x plus 4 on the left, and you end up with 3x plus 3 plus 1. Plus 3 plus 1 is plus 4. So you end up with 3x plus 4 equals 3x plus 4. And then if you subtract the 3x from both sides, it cancels. And you end up with 4 equals 4. That's kind of like this one. 3 equals 3. So what that means is no matter what you pick for x, 5, 2, negative 7.3, doesn't matter. Whatever you plug in for x, it will work. It's an equation that's always true. And I say it's true for all values in the domain because you're never allowed to plug in a number that would cause you to divide by 0. That's just not allowed. And you can't plug in a number that would cause you to take the square root of a negative. Okay. Those are two rules you always have to follow no matter what you're plugging into. Okay. Actually, that's similar kind of to the one I had up there, but that's also an identity. Versus a conditional equation, it's not an equation that's always true, it's an equation that could be true under the right conditions. The condition is you have to let x equal 5 in this case to make it true. Okay, any questions on any of those terms? Identity, conditional equation, equation. Okay. So to check and see if a number is a solution to an equation, you take that number, you plug it back in with a variable, well, for all the variables, and you see if you get a true result. So this could be an equation that's harder to solve by hand because it's a cubic. We don't have a formula that we know for solving a cubic. There is a cubic formula, like the quadratic formula. It's not as simple as quadratic. If you think quadratic's complicated, this thing is huge. It's not hard, it's very long. So it's not normally a formula that we teach. I don't know it off the top of my head. So I'm not going to ask you to solve this. I'm going to give you a number that is a solution to it, and I just want you to prove or verify that it works. Okay, so verify that -2 is a solution to that equation. All right. So Casey, how would I check that -2 is a solution to that equation?
Set the equation to -2.
So we don't want to know what value of x would make it equal -2. That's what would happen if we set this equal to -2. You'd be solving for what value of x makes it come out to -2. We know that this value makes it come out to 0. But we want to prove that this value makes it come out to 0. So what do we have to do with this?
Set x equal to -2.
Set the x equal to -2. Yeah. Which x?
The one that is not cubed.
Francesca?
Both of them.
Yeah, both of them. So you have to replace the variable everywhere with what they want you to check. And it's always a good idea to put it in parentheses, because when you raise something to a power that's a negative, you're raising that negative to the power as well. So the negative could cancel out. All right. So we have -2 cubed minus -2 plus 6. I'm going to put a question mark there because that's what we're trying to figure out. All right. How about Ethan? What's -2 cubed?
-8.
Yep. -8. And then Chris, minus -2
We would add 2.
becomes +2. Now -8 plus 2 is -6. And -6 plus 6 is 0 equals 0. So we just checked that -2 is a solution. Not saying it is the only solution, there might be more. There can be up to 3 real solutions. But that's definitely one. Okay. Any questions on that? So, linear equation in X. This is what a linear equation looks like. Has 2 variables. The way I should say it has 2 parts to it, usually a slope and a y-intercept. When we fill in for those, they're numbers. So the a and the b can be any real number that you want. That's what that sentence means. A and b are elements of the real number system, except a can't be 0. That's the only thing it can't be. Because if a was 0, then that would happen. And if you do that, now you've wiped out the x. That's now called a constant equation. That's not a linear equation. Linear equation has to have an x in it, with a slope that's not 0. So, let's see if we can solve a linear equation. This might not look like that, but it is. If you do all this out, you could make this equation look exactly like this. So a linear equation is not just anything that looks exactly like that. It's also something that could be rearranged to look like that. And this one could. Okay. What would be my first step here if I wanted to start to solve for x? Francesca? Okay, you're going to distribute. And Tyler, could you tell me what I get when I distribute out the 2 and the 3?
4x minus 6 plus 3x plus 3.
There's 3. That's a 3. All right, so that would be my first step. And Sarah, how about my next step? What would I still have to do on the left?
Like combine like terms.
Yeah, let's combine like terms. And Jake, if I combine 4x and 3x, what does that give me? 7x. And how about Ashley, if I combine -6 and 3? -3. Good. And Matt, what would I do next there?
Add 3 to this way.
Yep, I'm going to add 3. I like that. I'm going to add 3. What else can I do at the same time? Chris?
Subtract 5x from both sides.
Good. Subtract 5x. 5x. That's gone. So now I've got 2x equals 5. X equals 5/2. And that's how you solve it. Now I said earlier that you could make this look like that. We didn't have to do that, but if you wanted to, you would have done it right at this step. If I brought the 5 to the other side, I would have this. A number times x minus 5 equals 0. A number times x minus 5 equals 0. We rewrote it like that. That means it's a linear equation. Which means when you draw it, straight line. Okay, questions on that? All right. So, absolute value equations. So when we're solving an absolute value equation, just make sure I didn't skip anything. We have to split the problem into 2 problems. But before we split it, we have to make sure the absolute value expression is isolated on one side. This is what I mean by isolated. In that case, the absolute value is isolated because there's nothing outside the bars on the same side. Everything is inside the bars. Here's an example of one that is not isolated. Now you've got a times 3 on the outside of the bars. The first step would be to divide both sides by 3, to cancel the 3 on the left, and then get 4 on the right. Okay? Or if you had something like this, the first step there would be to minus 4 from both sides, to get the absolute value by itself. Now, if we think about it in this problem, you're trying to find a number that you can take the absolute value of, and it comes out to 12. Can someone give me a number you can take the absolute value of? And the answer is 12. Yeah?
What x is 10?
You don't even have to tell me what x is. Just tell me a number that I take the absolute value of, and I get 12.
So 10.
So this,
Oh, I thought you meant that equation up there.
yeah, don't even look at that. Just a number you can take the absolute value of, and it comes out to 12. Yep, 12. What else? Negative 12. So either in this one, what's inside these bars has to come out to 12, or it has to come out to negative 12. So as Ashley said, you could have 10 for x, or you could have negative 14 for x. Both of those answers would work. So to get the first answer, all we do is write down the original problem, except without the absolute value bars. So for this one, you would literally write x plus 2 equals 12 and solve. Or, the second answer is the same equation, again, without the absolute value bars, but we have to do one extra thing. We have to change the sign of the number on the other side. Okay, negate means change the sign. So in this case, x plus 2 equals negative 12. That would be my other equation. I'm not going to do that one. I got one right here we're going to do. But that's the idea. So let's see if we can solve this one. So first question we want to ask is the absolute value by itself? What do we think here? Is it by itself, Ashley?
Yeah.
Yeah, the absolute value is by itself. There's nothing on the outside of the bars. So let's split it into two problems. Ethan, can you tell me what my first problem would be?
What did you say?
Can you tell me my first problem, what it would be when I split it up?
You have to remove the absolute value signs.
Yeah, when we split it up, so the absolute values are going to be gone now, once we split it up.
Oh, you have to get rid of the 2x, like the variable on the x.
We're not going to rearrange everything yet. We just want to split this into two problems, just like we explained right there. So we're just going to split it into two equations. Help him out. What's going to be our first one we split it into, Tyler?
2x plus 3 equals 5.
Yes. 2x plus 3 equals 5. What's going to be my second one? Bailey?
2x plus 3 equals negative 5.
2x plus 3 equals negative 5. Okay, so those are the two that we're going to split it into. Now, solve each one for x. So in this case, you're going to get x equals 1. When you solve that one, when you solve the other one, you're going to get negative 4. And usually you put 4 between the two answers. X equals 1 or x equals negative 4. Okay, and that's how you solve an absolute value equation. Any question on that? All right, so I think the last thing before we finish up with quadratics is an application of linear equations, which is a mixture problem. So when we do a mixture problem, it's going to be setting up two equations. When they give us a mixture, they're going to want us to do two things. One, they want you to mix two things together to create a certain amount. So maybe when they're done, they want to have 10 gallons. And two, they want you to mix things together so that you have a certain concentration. So maybe you have like a 10% solution and a 20% solution. And they want you to mix the two solutions together to get a 12% solution. And maybe they want 100 gallons. So we have to set up an equation that represents the amount of liquid we want and an equation that represents the concentration of the solution. So the first equation, that one's pretty easy. You just take how much you need of the first solution plus how much you need of the second solution, and that's going to equal how much you need for the total solution. But that equation doesn't take into account the concentration, like the percentage. They'll tell you. So maybe if it was like a rubbing alcohol, you'd have like a 70% solution and an 80%. And maybe you need to make a 73% for your experiment. So you'd have to mix the two together in just the right amounts. And that's what the second one has to do with. And the pattern here is concentration of the first solution times the amount of the first solution plus concentration of the second solution times the amount of the second solution. And that's going to equal the concentration of the final solution times the total amount in the final solution. The concentration will always be given to you as a percent. But we have to change the percent to a decimal. So if you had something like 12%, you need to write it as 0.12. Okay, we want to have the two equations. All right, so let's look at an example where they give us two solutions and we'll mix them together to make something. So we have a 10% solution and a 25% solution. Just to be simple, since they've already picked kind of names for them, let's let A be the amount you need for the 10% solution, and let B be the amount that you're going to need for the 25% solution. I mean, you could do X and Y, but they already labeled them A and B, so let A be the amount of the 10, and let B be the amount of the 25. When we're done, we want to have a total of 15 liters, and we want it to be a 12% solution. So, just based on what they've given you, without doing any math yet, which solution do you need more of? Solution A or solution B? Yeah.
A,
How come?
because it's 10%, and it's, I don't know. I just thought I had it more.
Yeah, Ethan?
10% is closer to 12% than 25%.
Yeah. You want something that's just a little bit stronger than 10. So all you got to do is take 10 and put in a little bit of the 25, and that's going to make it stronger. So you're definitely going to have more of A. A lot more than B. All right, so let's figure out how much of each solution we need. Let's start with this one. Amount 1 plus amount 2 equals the total. How are we representing how much we're going to use of the 10% solution? Oh, Jake?
You repeat the question.
How are we representing how much liters we're going to need of the 10% solution?
A.
A. And how about how many liters, how are we representing how many liters we need of the 25%?
B.
B. So A plus B equals 25. So A plus B equals 25. And if that's all you knew, you wouldn't be able to answer it with just one answer, because you could do 1 and 24. You could do 20 and 5. You could do 12 and 13. There's lots of numbers that add to 25. But to get it exactly 12%, there's only going to be one answer. All right, so concentration times amount plus concentration times amount equals concentration times amount. So let's write that down. Concentration times our amount. Concentration times our amount. Final concentration, final amount. The final concentration they want is 12%. The final amount, I think it was 25 liters. What's the concentration of solution A? Francesca?
Is it 0.10?
Yep. So 0.10 or 0.1, same thing. And what's the concentration of solution B? So Casey. 0.25. Oh, I think I missed that. I mixed that up. Sorry. So they want the total amount of solution to be 15 liters. The 25 is the percent. So I mixed that up. The 25 is the percent. 0.25. So again, concentration times, they wanted 15 liters. Concentration, amount, concentration, amount, concentration, amount. 15. That's what we want. Okay, now we need to solve that. One thing we can do, I'm not going to rewrite the whole problem just to write this down, but 0.12 times 15 is 1.8. So the next time I rewrite this right-hand side, I'll put 1.8. Now, anybody know what we're going to have to do to solve this bottom equation? But you're going to have to use the top one to help you somehow. Remember how you do that. Yeah?
Elimination.
You could use elimination. The only thing about elimination here is since we have these decimals in front, we'd have to multiply by decimals up here. So anyone remember another method that you can use to solve something like this besides elimination? Bailey?
Substitution.
Yeah, we're going to use substitution. So in the top equation, let's get one of these variables by itself. Right, so Bailey, which variable do you want to get by itself?
A.
All right, so A equals, and can you tell me what A would equal if you get it by itself?
15 minus B.
15 minus B. Okay, A equals 15 minus B. You know what, even to make this more clear, I'm going to go like this. Now, what do I do with that 15 minus B? Yeah, go ahead, Chris.
Plug that in for A in the second equation.
Exactly. So this is kind of reviewing how you solve a system of equations that's linear using substitution. Okay, so let's do what that says. 0.1 times 15 minus B plus 0.25 B. I don't really need parentheses around the 0.25 and the B anymore. Equals, and I did 0.12 times 15. What was that? 1.8. All right. So Zach, what do I do next on the left?
Distribute.
Good. Distribute. That gives me 1.5. And that's going to give me minus 0.1b plus 2.5b equals 1.8. Matt, what can I do with that now?
You can combine like two.
Yeah. What do I get when I combine negative 0.1 and positive 0.25?
So you say where you get negative 0.1. You get a.
Well, that's bigger, right? The positive is bigger, so we're going to end up with a positive.
0.15.
Yep, I'm gonna end up with positive, let's see, 0.15b. Bring the 1.5 to the other side, and you're gonna be left with 0.3 on the right-hand side. So 0.15b equals 0.3. And Abigail, what would be my last step? Divide both sides by 0.15. And let's see, 0.15 is going to go into 0.3 twice. So B is 2. Let's go back up. So B was the amount of the 25% solution, which means how much do I need for the 10%? Yes, Chris?
13 liters?
13. And that makes sense because we said we needed a lot more of solution A, and that's the way it worked out. So that's how you can mix two things together to get a certain amount and a certain percent. Questions on that? The last thing we're going to take a look at is quadratic equations. So quadratics basically add in one more term. Instead of just bx plus c, now you have this term in front. The a, the b, and the c can be any number that you want. That's why I said a, b, and c are elements of the real numbers, except a cannot be 0. Why not? What would happen if a was 0? Yeah, Jake?
Then it would just be like the equation we were doing before, then it would just be bx plus c.
Yeah, it would just be linear. If you make a 0, then you wipe this out completely, and you're left with like a y equals mx plus b again. You're left with a linear. Right, so we don't want a to be 0. Does anybody remember the first way you learned to solve a quadratic before you learn the quadratic formula? This way only works if you have nice numbers. Remember, Ethan?
Isn't it like you have to factor it?
You can factor it, yes. So you can factor it, but again, this depends on having the right numbers to make that work. Not every quadratic equation is factorable easily. If it's not, we might want to do something else. But if it is, we can try to factor it. So let's try this one. First thing you always want to write down when you're factoring a quadratic is 2 sets of parentheses. And again, I hope all of this is pretty much review. Maybe the mixture problem, something from Algebra 1 you don't remember, but hopefully this stuff is pretty much review. What about your first term? That's what you do first. Anyone think they can tell me my first term in each parenthesis? Yep. Okay, an x and what else?
Another
An x and an x wouldn't give me 2x squared when I multiply. This would give me x squared. X times x.
oh, would be 2x.
The 2x, yep. And now there's rules. We don't really go through it in pre-cal, but there's rules for factoring. This is the middle term. This is the constant. The middle is positive. The constant is negative. That tells you what you need down here for signs. Does anyone think they can tell me if my signs are plus plus, minus minus, or one of each? Sorry?
Minus minus.
What is it?
Minus minus.
Okay, so if we do minus minus, think about when we FOIL this to check it. A negative times a negative would give me what kind of number?
Positive.
It would give me a positive, and we need this term at the end to come out negative. So it's not minus minus. Yep, Sarah?
Be a positive, plus sign.
Yeah, one of them has to be a plus sign, and it does make a difference which one. I would try this one, because that's the one that works. So we have a minus and a plus. If you need that chart, so middle, constant, you could have a plus plus, plus minus, minus plus, minus minus. So then when you're factoring, let's go like this. So then when you're factoring, if it was a plus and a plus in the original problem, you would want two pluses. If it was a plus and a minus, that's what we have here, you would want one of each, not necessarily in that order, but one of each. A minus and a plus. When you factor, you would want two minuses. And a minus and a minus, that would be one of each again. Not necessarily in that order. So look at the middle. Look at the constant. Positive, negative. Positive, negative, one of each. That's the quick chart I kind of do in algebra. All right. Now the last thing we need is two numbers that multiply to give me 3. Since 3 is a prime number, there's only one way to do it. So two numbers that multiply to give me 3. What can I use? Yes, go ahead, Jack.
1 and 3.
1 and 3. I like that order. Let's check it. That's 2x squared plus 6x, take away 1. Okay, I'm just distributing it out. Plus 6, take away 1, perfect, plus 5. And negative 1 times 3 is negative 3. Okay, so that's the hard part. Yeah.
Is it okay to do like the extra step where you multiply the A and C value and then find it?
Yeah, there's lots of different ways to factor. So if you have a method that you've used, I might want to kind of hear you explain that, just to see, because it would be interesting. You don't have to do it right now, but I'd just be interested to see about what you just said. To see, it helps you to factor it a little easier. Yeah?
It's a lot easier.
So now we've got two factors equal to 0. What's the only way that you can multiply something times something and get 0 as an answer? Yeah.
Multiply by 0.
Right. The only way you can multiply two things together is if one of these is 0, or both. So either this has to equal 0, or that has to equal 0. Now, what value of x would make the one on the left 0? Say it again.
1.
So what's 2 times 1?
So then 2. I mean, sorry, then 5.
So 2 times a half is 1. Take away 1 is 0. That works. And Abigail, what would make this one 0? Negative 3. So those are both of the answers. Okay, so that's that. Any questions on that one? Now, if factoring doesn't work, then we have to use the quadratic formula. Now, you can use quadratic formula all the time, even on a factoring problem. It's just, if you're good at factoring and you can do it quickly, most of the time somebody's going to be able to factor faster than quadratic formula. If you're good at factoring. Now, Now, if you had a quadratic equation and you had numbers that were in the thousands and you had to try to factor it, that's probably going to be kind of challenging. Quadratic formula might be easier to do. And that is the quadratic formula. Remember that A, the B, and the C come from here, here, and here. So you have to make sure that your equation is equal to 0 first. Then write down the A, the B, and the C. That's what I'm saying right there. So make sure that it is in standard form. Let's try this one. 2x squared plus 2x equals 1. 2x squared plus 2x equals 1. All right. So, what's the first thing I should do with this one if I'm going to attempt to solve it with the quadratic formula? Yes, Jack?
Subtract 1.
Yeah, let's subtract 1. We don't want to accidentally think c equals 1 because c is not 1. And then off to the side, I'll write down a, b, and c. Casey, what's my a? 2. And Francesca, b?
2.
And c, -1. Now, from here it's easy. Just fill those three numbers into that formula. Just use the right formula, but since you can make a reference sheet, really shouldn't be any reason why you have the wrong formula. Make sure you copy that down. All right, so -b plus or minus square root of b squared minus 4 times a times c. A is 2, c is -1, all over 2a. When I multiply that out under the root, I'm going to have 4 minus. I'm going to end up with minus a minus. So what I'm going to do right now is just change it to a plus. And what do we get under the root? Sarah? Yeah, we're going to get 12. So 2 plus or minus square root of 12 over 4. But square root of 12 can be simplified. Anyone tell me how we can simplify the square root of 12? Not a decimal, but we can reduce it, yeah?
2 times the square root of 3.
Right. The square root of 12, and there's different ways to do it, but I think of it like this. 12 is 4 times 3. So think of the square root of 12 as the square root of 4 times the square root of 3. Square root of 4 is 2. Square root of 3. And then, sometimes when you do that, you can look at all the numbers that are outside roots, and they're all divisible by something. In this case, all divisible by 2. So 2, 1, 1. So final answer, when you reduce it as much as you can, -1 plus or minus root 3 over 2. And that's quadratic one. The other thing about the quadratic formula is it's the only way to get the exact answer to a quadratic equation, if it doesn't factor. So on the test, if I ask you for an exact answer, and let's say you plug this in on the calculator. You plug what's on the left in y1, you plug what's on the right in y2, and you calculate where they intersect. The calculator isn't going to write this on the screen. It's going to write a decimal. Okay? There's really no way to convert that decimal into that. So if I ask for an exact answer, that's how you get it. Okay, questions on it? Okay. So that's homework for tonight. 35 to 39, that's just a break-even problem. Find a graph and calculate where they cross. That's basically all those questions. And then page 96, that says 1 through 4, 9, 11, 13, 19, 25, 26, and then 37, 38, 52 to 54, and 58. That's on solving linear and quadratic equations. So tomorrow we'll take a look at that, and then we'll take a look at section 2.4. It's the plan for tomorrow.